Hi everybody. So for today's lecture, we are going to continue building up on the concept of um, electrical impulses that are spread through the heart, our ability to actually measure it using the ECG or EKG, creating the three waves, P wave, QRS complex, and the T wave. Now we're going to basically connect that ECG concept to a cardiac cycle, which basically the three steps that allows the heart to effectively circulate blood within itself as well as through your pulmonary and your systemic circulation. Couple of vocabulary to start with, which you also already heard before during the blood vessel lecture. Starts with the word systole and the diastole. The word systole implies that contraction of the heart, regardless if we're talking about ventricles or atria, is a general vocabulary to describe it. However, usually when we talk about systole, we're focusing on the ventricle and its contraction. The word diastole, on the other hand, represents the period of relaxation, which again can be associated with both ventricles or the atria, but we do usually focus on ventricles and their step associated with their with filling with blood before their contraction. Now, when we're talking about cardiac cycle, you do need to again understand and remember that atria is going to basically contract first to push as much as blood to the ventricles before ventricular contraction that pumps blood through both either the pulmonary circulation or your systemic circulation. Now, there are three main steps involved in the cardiac cycle. The first one is referred to as the ventricular filling. So, ventricular filling is described, and we'll go over into more detail, but basically describes the first part of the process, or sorry, the second part of the process, as the heart is basically filled with blood. Atria push as much as blood down to the ventricle. We have the second step, which is ventricular systole. Simply put, is when ventricles are contracting. And then the last one is isovolumetric relaxation, which comes immediately after ventricular systole, where your ventricles are starting to relax and atria is starting to fill the ventricles with blood. Now, this is a very generic overview as I described so far. So let's go ahead and take a look at these three steps or processes within the cardiac cycle. Let's start with the first step, which is ventricular filling. So think about your heart. You have the two atria chamber on the top and you have the ventricles on the bottom, right? So if you're looking at this being basically your heart, you have your two atrium up here and your ventricles down here. So by just looking at the gravity, as blood comes into the two atria, it's going to move directly down to the ventricles with the use of gravity. Now, this happens about 80% of, 80% of the blood going to the ventricles use that flow and passively moved from atria down to the ventricles. Now, during this time, because blood is freely flowing from the atria down to the ventricle, that implies that the AV valves are going to be open because, again, you have free flowing blood going down to the ventricles. But at the same time, because ventricles are still filling up with blood, at that stage your SL valves are already closed. They're not closing, but they're already closed. Now, as ventricular filling step is coming to an end, the atria, the superior part of the heart, is going to squeeze or contract and basically push as much as blood down to the ventricles. Now, when this step is done, that's about, by the way, about 20% of the blood that was remaining gets pushed down to the ventricles. The amount of blood that has now covered or filled the ventricles is known as end diastolic volume. We'll see this over and over again later, and it's in shorthand to EDV, end diastolic volume, which basically comes in as ventricles is relaxed and diastolic, and it's basically the maximum volume that your ventricles can be filled. Now, as the ventricular filling step or phase is coming to an end, your atria is going to basically finish up its contraction and it's going to start to diastole, which means basically it starts to relax and continue being filled with blood. And as this step again is finishing up, ventricles are getting ready to contract. This also, in the sense of your graph, it is representation of the P wave as well as the QRS. Now that your ventricles are basically filled with blood, they are now ready to contract. So going back to the whole idea of your four chambers of the heart, what you have basically is your ventricles filled with blood right now, and some of this blood wants to go out, and I'm just going to draw this as the pulmonary trunk. And then from this ventricle on the left hand side, you have the main blood vessel aorta coming up. I know it's not anatomically correct, but I just want you guys to have an idea. So covering right here on the pulmonary trunk, you have the pulmonary valve or pulmonary semilunar valve. And on this side, you have your aortic semilunar valve that are closed at this stage. So ventricular systole has two stages. So let's look at these. As ventricle starts to contract, the word systole, what you're going to do is you're going to start to push blood, basically contract these units, and you're going to start to push underneath the AV valve, which are located right here. And as blood is being pushed underneath the AV valves, it's going to cause the AV valves to basically close up. So blood is being pushed underneath as the ventricles contract. So these two valves are going to come to a closed phase. So your AV valves basically close up. Now, as the AV valve close up, your semilunar valves are also closed up. So that means that there is no change in the volume of your ventricles, but the pressure is building up. So iso implies equal. So isovolumetric means equal amount of blood, so there's no increase or decrease in blood volume. And during the contraction phase, right, because ventricles is contracting. So this is a process called isovolumetric contraction, which again, all four valves have been closed, so no extra blood is coming into your ventricles, but your ventricles still continue to squeeze and build pressure. So as the pressure is building up, so there is an increase in pressure in both of these chambers, what you'll see is that the pressure as it builds up, it's going to be higher than the pressure that is in your pulmonary trunk and in your aorta. The buildup of pressure in the ventricles now is going to open up your semilunar valve right here and semilunar valve right here, and basically allow the circulation to allow the blood to go through the pulmonary trunk and through your aorta. Typically, this pressure in the aorta is about 120 millimeter of mercury. That represents your normal systolic blood pressure. Now, by the end of this stage, basically you emptied as much blood as you can. So at the end of this stage, you get the volume that is left inside your ventricle called end systolic volume. End systolic volume, volume of blood that is remaining inside your ventricle after they're done their contraction. So let me give you a couple of numbers. The end diastolic volume that happens when the ventricles are relaxed is about 120 milliliters. And when your ventricles are done with contraction and systolic volume, that's about 50 milliliters of blood that is left inside the heart. So the difference between these 120 minus 50 gives you about 70 milliliters of blood, and this 70 milliliters is described as a stroke volume, basically the amount of blood your heart can pump at every given cycle. And again, we'll come back to this later on when we're talking about cardiac output. Now, during the previous step, as I mentioned, your ventricles contracted, opened up the semilunar valve, blood got pushed out. So anytime you have a contractile action, contraction is followed by relaxation. So this stage is known as early diastole. Early diastole is implying that ventricles are starting to repolarize and therefore they're starting to relax. It's also known as isovolumetric relaxation. So how does that happen? Going back to the picture that I draw, you have your blood vessels, right? Ventricles, ventricles, your blood vessels, blood vessels. You are relaxing the ventricles right here, correct? So as your ventricles start to relax, there is an increase in volume, and that leads to a decrease in pressure inside your what? Inside your ventricles. So pressure starts to drop right here. There is a decrease in pressure inside your ventricles. As a result, what happens is blood that is moving right here in the aorta and in your pulmonary trunk is want to backtrack into your ventricles. In this case, what are you going to do? You're going to close up your semilunar valves that are right there and the semilunar valves that are right here. So as pressure inside the ventricle starts to drop because your ventricles are relaxing, your semilunar valves are going to close up right here and right here to prevent the backflow of blood down to the ventricles. So at this stage, you close up your semilunar valves, and if you guys remember, you already have your AV valves closed as well. So these valves are already closed, the AV valves closed, and your SL valves just closed up as well. So in this case, what you have, again, you have isovolumetric, which means no change in the volume of the heart, which is about, if you guys remember, it's about 50 milliliter of blood, and your heart is in a relaxation phase, or more specifically, your ventricles are relaxing. So basically, you are in isovolumetric relaxation. Now what happens is, as the AV valves are closed, what is the atria are doing? Atria are getting a lot of blood into them, right? So basically, as blood is coming into the atria, either on the right-hand side or the left-hand side, there's going to be an increase in volume. An increase in volume causes an increase in what? Pressure, exactly. So there's a buildup of pressure right here. So when pressure in the atria becomes higher than the pressure in the ventricles, then what are you gonna do? Pop these valves open. So what you're gonna see again is valves open, valves open. So blood's gonna flow down to your ventricles, and now you're gonna have basically the normal filling of the ventricles. And this stage is followed by mid-late diastole and another ventricular systole. So the three steps are, again, increase, basically you fill up the ventricles, you contract the atria, then you contract your ventricles, push the blood out by opening your semilunar valves. Then when your ventricles relax, you close the semilunar valve and you wait until the pressure in the atria increases enough to open up the AV valves and push blood down to the ventricles. Now this picture looks really confusing, but there's a couple of key things that I need you guys to know. First thing is, let me actually go one more slide and I'll come back to that. There's two heart sounds that are created inside your, when you actually listen to your heart. One is called the lub, the other one's called dub. Lub sound is associated with closing of the AV valves. As you notice, the AV valves closed up first. And then dub sound is associated with closing of the semilunar valves as the ventricle starts to relax. Now we know that there are two sounds, lub, dub. So let's take a look and associate that with basically the cardiac cycle. So on the top line, what you have is basically an ECG, P wave, QRS complex, and T wave. Right here, what you see right here is basically the lob sound of your heart, and this is the dub part of the sound. So AV valves closing, semilunar valves closing. The other line that is really important in this graph is the pressure associated with your ventricles. Now I don't really want you guys to know all of the lines here, but the really important one is the pressure built up as you start to basically contract your ventricles. So notice here, lob means the AV valves are closing as the ventricles are start to contract. So you close the valve, you have already semilunar valves closed. So what happens is you're building up the pressure inside your ventricles. Eventually, the pressure reaches the maximum, which is about 120, and this causes the SL valves to open. Blood pushes out, and as blood is pushing out, what happens to the pressure in the ventricles? What happens to the ventricles after they contract? They start to relax, which means the pressure starts to go down. And then notice, as the pressure starts to go down, what are you going to do? Close up your semilunar valve, which happens somewhere right about here. The other one that I really need you guys to know in this graph is the line you see right here. So as your atria is contracting, it's going to push as much as blood into the ventricles, right? That last 20%. So your end diastolic volume, basically when ventricles are relaxed and are filled with blood, is about 120 milliliters, what I wrote to you earlier. As ventricles contract, you see right here during the contractile phase, you end up with about 50 milliliters of blood inside your heart, which represents end systolic volume. Basically, how much blood is left inside your ventricles after it has gone through contractile first. So the difference between them, what I showed you earlier, the difference between them is known as a stroke volume, which is about 70 milliliters. So keep those in mind. We will visit them again in your next presentation. Last part of this PowerPoint, we're going to focus on the 4 sounds of the heart that can be heard using an stethoscope. So we have 4 locations for them. If you want, you can learn more detail about them as far as the second intercostals. But basically from this picture, what I want you guys to understand is this. If I want to listen to the aortic semilunar valve closing properly, I listen to the superior region of the superior right-hand side of the heart. If I want to listen to the pulmonary semilunar valves or pulmonary valve, I listen to the superior left-hand side of the heart, because pulmonary trunks moves to the left and then branches off to the right and left. Aorta first goes to the right, so the semilunar valve, aortic semilunar valve, is heard on the right side of the heart. On the inferior aspect of the heart, on the left-hand side, you are going to hear the mitral or the bicuspid valve, and on the right-hand side, on the inferior part of the heart, you're going to hear the tricuspid valve. Another way, by the way, if I want to look at or hear the mitral valve, is by listening to the apex of the heart. That's the best place to put it to hear the mitral valve. A lot of heart murmurs associated with your damage or problems with mitral valve. Now, connecting that to a couple of homeostatic imbalances, we already discussed heart murmurs in a previous slides when we talked about the valves, but just kind of going over that. Heart murmurs is any abnormality within the sounds of the heart associated with the valves of the heart. One of these problems could be called the incompetent or insufficient valve, which basically means the valve is not closing up properly, which allows the blood to backflow to the chamber. When you listen to the heart sound and you listen to those 4 locations, if the valve is not closing properly, then you hear a swishing sound in addition to the valve closing. So it comes right after, which means the backflow is taking place. A stenoic valve is another one we discussed earlier, is when the valve are very basically tough or hard to move or open. So blood movement through the valves is actually restricted. This actually creates a relatively high-pitched sound or clicking as the blood is going through the valve because the space where the blood is passing through is relatively narrow. Okay, I'm going to stop here and then we'll continue in the next presentation discussing cardiac output and how does that change based on your heart rate and stroke volume.